Alright, today we are going to start unit on polynomials, starting with reviewing a concept from Algebra 1, which is using properties of exponents. So not a bit of this is new, all should be reviewed. So you've got all these properties over here on the left side, that's the name of the property. Here I'm showing you an example of the property, and then we're going to describe that in words. Then we've got kind of a little baby example of each, and then a whole bunch of them for you to try and see how you do. So, product of powers. So, describe. That means say in words what you see happening here. So, what we see here is that we have two powers multiplied, which should make sense because product means to multiply. So, what happens when you multiply those, if you look here, is that the exponents get added. So that is what we are going to write for the description. I wanted that to be blue. There we go. When you multiply powers, add the exponents. So, real quick, simple example. Over to the right of that, here we're multiplying powers, so we should add those exponents. The base stays the same, so 3 plus 5 is 8. So the answer there is x to the 8th. Next, I have power of a power. So we're taking a power and raising it to another power. So for these ones, the rule is for power of a power, you're going to multiply the exponents. So that's what we see happening to the left. So on the right, we are going to do that. So we take those two exponents and we multiply them together. 4 times 3 is 12, so y to the 12th would be that answer. On the next one, power of a product. So basically, we've got a product inside the parentheses, and then we're taking that to a power. The big idea here with the parentheses is that all terms inside parentheses, I'm just going to put, instead of writing the word out, have to be taken to the power. So that you'll see over here, the a got the m exponent, and so did the b. So over here, we have to make sure we take each of those terms inside to the 6th power. So x squared to the 6th would be x to the 12th, because we would multiply those exponents. Y raised to the 6th power is just y to the 6th, so that would be our solution there. Negative exponent rule. So when you have a negative exponent, you cannot leave that in your answer because it's not in simplest form. So no negative exponents in your answers ever. And the way we deal with negative exponents is that we make negative exponents positive by using the reciprocal. So we take this power and we reciprocal it. We put it in the bottom, and when we do that, we make the exponent positive. If something were already in the bottom, then reciprocal would mean to bring it to the top. So here I've got an example here. Notice that this is the only part that has the negative exponent. So that x to the 3rd, we're not doing anything with it. It's staying. But that y to the negative 4th, we could make that for a positive when we reciprocal its term. So x cubed over y to the 4th would be the answer there. 0 exponents, easy rule. Anything to the 0 power is always equal to 1. So again, that doesn't mean all of this is 1. You don't just write a 1 anytime you see the 0. But this term is going to be a 1. So we've got x to the 5th times 1, which would just give us x to the 5th. Quotient of powers, if you look at what's happening here, they have the same base and we're dividing. That's what quotient means. So when we're dividing powers with the same base, it looks like we subtract the exponents. And so then our little example over to the right side, these have the same base, both base y. Since it's division, we're going to subtract the exponent, so 5 minus 2 is 3. So that's y to the third power. Last rule and example is power of a quotient. And really, this and the power of a product, it's the exact same idea, except that one has division and one has multiplication. But they're going to have the same description because the big idea is that all the terms that are inside parentheses have to be taken to the power. So over here, that x squared needs taken to the power, so power of a power there would be x to the 8th. Same thing on the bottom. I would multiply the 3 times the 4 to get 12. Hopefully this refreshes your memory and you now feel comfortable saying that you can meet this learning goal, that we can use properties of exponents to evaluate and simplify expressions with powers. So all of example 1, because we really did already on the right side up here do an example of everything. I really would like for you to try these problems because that tells you how good you are at applying these rules. So I'd really like for you to try them all and keep it paused and then come back and just watch me work through them, and hopefully you get most of them right. All right, so on A, we have to apply power of a power here. So 4 times 2 is 8, so we've got 3 to the 8th over 3 to the 9th. Then we have division with the same base, so the rule is to subtract the exponents. 8 minus 9 is negative 1, so 3 to the negative first power. We can't leave negative exponents in the answer. So we reciprocal it, and that'd be 3 to the first on the bottom. I don't need to write the 1 here because we don't write 1 as an exponent. We leave it off whenever that happens. So the answer to A should be 1/3. B. So first thing I would do here, and there's multiple ways to approach this, so if you didn't start it just like me, that's okay. What I did first is I said, okay, I'm multiplying two things that have the same base, so I'm going to add the exponents. So the base is negative 2. When I add the exponents there, negative 3 plus 9 is positive 6. And so in this case, because the base happens to be a number, we actually do need to simplify that. So you need to press into your calculator, negative 2 raised to the 6th power. Make sure you actually use the parentheses. Remember, if you don't, it's going to tell you that it's negative 64, when really the answer should be positive 64. C. So you've got a couple different options here. I worked inside the parentheses first. So here I had power quotient, so I have to take both the numerator and the denominator to the second power. So 3 to the second power is 9, and 4 to the second power is 16. So I did that first. And then I still have to do this 3 here. And so I have to take each of those to the third power, so it's going to be 9 to the third power over 16 to the third power. So 9 to the third power is 729. 16 raised to the third power is 4,096. Now you would probably want to see if that would simplify, but even with the help of your graphing calculator, they have 0 common factors, nothing in common, so there's nothing else we can do there. 729 over 4,096. All right, next, this one gets a little tougher because we've got a lot going on, and we have to separate things that do not have the same base, and we kind of work them as three separate parts. So here we've got our first part is just the plain old numbers, then we've got x's, and then we've got y's. So I'm just going to look at the plain numbers first. If I've got -3 divided by 12, I just reduce that. So that's going to be -1/4. And then I look at the x's. The x's, if I have x over x to the third, I would subtract the exponents. 1 minus 3 is -2. Down here, when I subtract those y's, 2 minus -5 is +7. So this is what I have in my first step. I then need to simplify because I can't leave this negative exponent in my answer, so it needs to move using the reciprocal property down here bottom with the 4. So I've got 4x squared, and I don't need the 1 anymore. And then I've got -y to the 7th in my top. All right, on E, what I see here, bunches of different ways to do this one as well. What I'm going to do is I'm going to do this part first. And people always get tricked by this. This negative there is really a -1. So when you have parentheses and a power on the outside, everything in there needs taken to the power. So that -1 needs raised to the 5th. And then I also take the y squared to the 5th. So that's power of a power, so I would multiply those exponents. And then I'm going to combine these two while I'm at it. Same base, so when I multiply, I add those exponents. So those are give me y to the -10 when I combine those two. So now -1 to the 5th is just -1. Y to the 10th times y to the -10th, when I add those exponents, that becomes 0. Y to the 0 is just 1. So -1 times +1 is just -1. So that whole expression with all those y's just simplifies right down to a -1, and that's it. On F, here, again, multiple ways that you could approach this. You can get rid of this negative exponent first if you want, so bring it up so that you've got 2a squared b cubed, and then apply your power rule. Remember, everything in there needs to get the third power, including that 2. So 2 to the third, and then there I would multiply exponents. So I get 2 times 3 gives me 6, 3 times 3 gives me 9. Now the only thing left to do is to simplify that 2 to the third, which is 8. So 8a to the 6th, b to the 9th. On G, again, multiple ways that you can approach it. I'm going to focus on this area first. So I'm going to keep my numerator just how it is for right now. Over here, that r needs raised to the third, and that s to the -1. So when I multiply those exponents, gives me this. So now you can either get rid of the negative exponent first, or I just kind of prefer to do the whole separated out. So I'm going to do the 6 divided by 1, which is just 6. Then I'm going to look at my r's. This is really r to the first. If nothing's written, it's an understood 1. So when I'm dividing, I subtract the exponents. 1 minus 3 is -2. So r to the -2. Then I've got 2 minus -3, so that would become 5, so s to the 5th. And then 4 minus 2 on the t's gives me 2. So final step then, since I haven't gotten rid of the negative exponent yet, is to deal with this, so this part needs to be reciprocal. Everything else can stay. So I've got 6s5t2 up, and in the bottom, that r squared that I had to reciprocal. All right, H. Again, on most of these, there are a lot of different ways that you could start these and still get the right answer. So some people prefer to simplify first and then multiply. Some people like to multiply and then simplify. Again, I don't care which way you choose as long as you get the right answer. So I am going to go ahead and multiply first since the numbers are relatively small. So 3 times 2 gives me 6. And then the variables, these aren't the same, so those are just going to stay, and I put them in alphabetical order, so x cubed y squared. On the bottom, I do have some like variables here, so the 4 comes along, x times x is x squared, and then I've got my y. So now it looks very similar to what I had in G as well as what I had in D, so deal with each piece separately. So 6 divided by 4, that doesn't come out evenly, but it does reduce. So I need to make that a 3 and a 2. My x's, 3 minus 2 is 1, so x to the first. And then on the y's, remember this is an understood 1 if nothing's there, so 2 minus 1 is 1. So that's going to be 3xy over 2. All right, very last one. And again, you can choose whether you want to simplify first and then multiply or vice versa. Here, again, the numbers are relatively small, so I'm just going to go ahead and multiply first. So 3 times 6 is 18. X squared times x cubed, you add the exponent, so that's going to give you x to the 5th. Y to the first times y to the 5th, that's going to give me y to the 6th. And then bottom times bottom, 4 times 12 is 48. Then these don't have any like variables, so just go ahead and bring them both over as they are. And now I just need to reduce. So when I'm looking at these, remember I want to find the biggest factor that divides both of them. So I believe that that is 6. 18 divided by 6 is 3. 48 divided by 6 is 8. So that reduces to 3/8. Then I've got x to the 5th in the top and x to the 5th in the bottom. So those are going to be x to the 0, which is 1. They cancel each other out. On the y's, 6 minus 4 is 2. So I've got y squared. So then nothing else to simplify there. My answer is going to end up being 3y squared over 8. So go through and double check. You want to make sure that you've gotten all of the right answers there. And if there was one that you didn't understand, maybe go back and watch it again. It's really important because we're going to be in this unit, we're studying polynomials, and there's going to be all kinds of exponents everywhere. So it's really, really important that you are able to simplify all of our exponent issues. All right, well, I think that that is it.